So in this problem, we're trying to solve for that value, which looks like it's a hypotenuse of the triangle on the right. And so we'd like to use a squared plus b squared equals c squared. The problem is we don't have this other leg. We know the bottom leg is 7. We're trying to find the hypotenuse x. So I need to find this first. So it's really a two-part Pythagorean theorem problem. I'm going to solve that side using the triangle on the left first. If you remember your Pythagorean triples, 3 and 4 and 5 is how we can solve that. So very quickly, if you've got it memorized, you know that that's got to be 4. If you don't have it memorized, it would look kind of like this if you use the Pythagorean theorem and say that one of my legs is 3, one of my legs I don't know, that's what I'm trying to solve for here. It ends up being 4. And then your hypotenuse of 5, and as you work your way through that, that's another way that you can get to 4. Either way is just fine, but you want to get to the point where you recognize that that vertical line is 4. Because now when we look back up to the triangle here on the right-hand side, now you see that we've got 2 of the legs. And so I can plug in 4 for my first leg and 7 for my second leg. So I'd have 4 squared plus 7 squared equals, if you want to call it c squared, that's fine, or if you want to change it to x, that's fine too. So now we'd have 16 and 49 equals x squared. And so when I add those two together, I'm going to get 65 equals x squared. And then I've got to take the square root of both sides. So x equals the square root of 65, which is this value up here. Square root of 65, well, square root of 64 is 8, so this is going to be just a little bit higher than 8 if you're looking for a more specific length. But we can keep it at that specific value, square root of 65.